Okay, let's do, I asked you over the weekend to do 1 to 4 in this sheet, and then last night 5 to 8. So let's go over these before you go on, just because I want to make sure that you're doing them correctly. Okay, so the first one says a boy is pulling with a horizontal force of 50 newtons on a 300 Newton wagon. So draw your diagram, draw in all the forces. They are vectors, they should have arrows. Label them. So you're pulling with 50 newtons. The 300 Newton wagon is actually the weight of the wagon. Okay, so it's Fg. And from that you can find M, because we know Fg is equal to mg. So M is just equal to Fg divided by g. So 300 newtons over 9.81 meters per second squared. So that'll tell us what the mass of this wagon is, okay? So whenever I give you weight, it's really Fg. So it's 30.581. 30.581 kilograms. All right. It tells us the coefficient of friction is 0.1, and it wants to know what is the acceleration. Now, for those of you I haven't taught before, I know that in grade 11 you did it in bits and pieces. We tend to put the pieces together, so even if you got the right answer, I would like you to watch these just to see the technique I'm going to use, because it's going to make the tougher ones that are coming up easier. Okay? So what we always do, we learned from Newton's second law last year that F net is equal to ma. But I think I already said to you at one point, instead of F net, I tend to write the sum of the forces. Okay? And so we will always do the sum of the forces in the y direction, which will be equal to may, and we'll do the sum of the forces in the x direction, which will be equal to max. Okay, so these will always be our steps. So we will start, number 1 then, with the sum of the forces in the y direction. Well, this wagon isn't moving in the y direction, so this goes to 0. In place of where we have the sum of the forces, we write down what forces do we have in the y. We have Fn and we have Fg. Fn's going up, Fg's going down, so we end up getting that Fn equals Fg, equals the 300 newtons. Yes, I know that's obvious, but I'm just showing you these steps because they will work no matter how complicated the problem gets. So we're going to start using them on the simple problems, and so that by the time we get to the complicated ones, you'll be good to go. Now we go to sum of the forces in the x direction. And in the x direction, we have two forces. We have F going one direction, and we have friction going backwards. And that's equal to max. Now, friction, we know, again, from both grade 11 and yesterday when we reviewed it, it's just equal to mu Fn. So you could go on the side and do that, or you could just write it in here. You could do F minus mu Fn is equal to max. And the question's asking you to solve for A. And so divide both sides by m. So ax equals F minus mu Fn divided by m. So for those of you that already filled your numbers in, don't. Steps in problem solving is rearrange for the unknown and then fill in your numbers. So now we can fill in our numbers. If I could only move the paper so I could actually have space. So this will be 50 newtons minus 0.1 times 300 newtons. And then that is over the 30.581 kilograms. So on the top, 50 minus 30, that's about 20, divided by our mass that we just found. No need to round because everything is there in your calculator, all the digits for the mass. So 20 divided by that, you get 0.654 meters per second squared. Second part of the question, I just need to pull the sheet out so I can see it, asks how far did it move if it started from rest? So then that's kinematics. Delta D is equal to VI delta T 1/2 a delta t squared. Started from rest, that goes to 0. Delta d is equal to 1/2. That's 0.654 meters per second squared we just found. And it said how far in 2 seconds, which you're going to square. So 2 squared is 4. Half of 4 is 2. 2 times 0.654, so you're just doubling it. And so you could probably do that in your head. It should be 1.308 meters. Okay, so our two answers. And there is number 1. Number 2 says, a hockey puck is given an initial velocity of 20 meters per second. It slides 120 meters before coming to rest. So VI is 20 meters per second. Delta D is 120 meters. Coming to rest, VF is 0. From these three, we can find A, because we know VF squared is equal to VI squared plus 2A delta D. So rearranging for A is equal to VF squared minus VI squared over 2 delta D, and the VF is 0. So this is negative 20 meters per second, and that gets squared, so it's going to be 400, divided by 2 times 120, so 400 over 240. 80 goes into both of those. And you should get, I think, 1.6 repeating, right? 5 over 3, yeah, 1.6 repeating. So, and it's negative. Negative because it's slowing down. Meters per second squared. But that's not what the question asks. The question wants you to find the coefficient of friction. So we go back to the forces. In the y direction, you have Fn and Fg. In the x direction, the only force you actually have is friction, acting backward, right? Because after you hit the puck, you don't follow it down the ice pushing it, so it's the only force is backward. So again, if we do some of the forces in the y, it'll be equal to MAY, which will be 0. So again, we'll have Fn minus Fg equals 0. So again, Fn equals Fg, but we don't know what, I don't tell you the mass of the puck, so all I know is that Fn equals mg. I can't go any further than that with the puck, in the y direction. So now I go to the x direction. Sum of the forces in the x direction is equal to max, and there's only one. It's friction, and it goes in as a negative because it's acting opposite the motion, right? If you were pushing or hitting it, it would be going forward. So friction is a negative, and we know that friction is mu Fn. So we have minus mu Fn is equal to max, and we know Fn from right here is mg. So mu mg equals max. We're solving for mu. So divide both sides. So mu will equal negative max over mg. The m's cancel. So you have a negative 1.6 repeating meters per second squared divided by 9.81 meters per second squared. And when you do that, you get 0.1699 maybe? 0.1699 units cancel, the end. Number 3. Number 3 says you're sliding an 80 kilogram box along a horizontal surface. Coefficient is 0.4. It's accelerating 2.5 meters per second squared. What is the force you're pushing with? So draw in all your forces, put friction in here, do some of the forces in the y direction. Again, this box is not moving in the y, so it'll be Fn minus Fg equals 0. So Fn equals Fg equals mg, which you could find if you want, but you don't need to find it right now. Just leave it. No need to put in numbers yet. Now go to some of the forces in the x direction. In the x direction, we have two forces. F is going one way, friction is going the other, and that's equal to max. The question is asking you to solve for F. So take friction to the other side. F is equal to max